All right, so the income tax is assessed using this function below. This is a very simple structure with only 3 different kinds of tax, right? So if you make under $15,000, you pay no tax. If you make between $15,000 and $30,000, you pay 12%, and if you earn greater than $30,000, you pay 18%. So if this is your income, you should have figured out that number is between $15,000 and $28,000, and I saw a lot of you wrote 12% tax, which is good. But they also want to know how much tax you will pay. So we have to find 12% of what number? Excellent. So 12%, we're going to use what decimal, Brenda? Very good. Okay, so we're going to do 0.12 times 28,000. And did you guys get 3,560? Yeah? No?
360.
Yeah, I couldn't read my 3. You're right. 3,360. All right. If your income is $14,000, what tax do you pay?
0.
Nothing. Okay? So that's good. If $14,000 is less than $15,000, so you pay $0 tax. All right, last year your income was $25,000 and your friend's income was $32,000. How much more did your friend pay in taxes than you? So you had to find the tax for both people, right? So $25,000 is in this middle bracket, right? So we're going to do 12% of 25,000. And then 32,000 is in the last bracket, so we're going to do 18% of 32,000. So I got 3,000 and 5,760. Did you guys get those numbers? And to find how much more my friend paid, I just do what? Just subtract, yep. Remember in IB they ask you to show every step, so you want to show that step too? What percent tax would you pay if you made exactly $30,000?
12%.
I heard a vote for 12%. Anybody agree with 12%? A couple people are agreeing. Anybody feel strongly it's 18%? All right, let's look. Right, because 30,000, this is less than or equal to, but this one doesn't have an equal to. So 12% if you made 30,000. All right, we're going to talk about composite functions. Composite functions are when you put a function into another function. So it's called a composition. You're composing the two functions. They have a slightly different notation in IB than you may have seen in previous classes. This is also an Algebra 2 topic. So you should have studied this in regular Algebra 2 or in Honors Algebra 2. All right, so given f of x and g of x, the composite function of f and g will convert into f of g of x. So this is how you may have seen it written in Algebra 2, f of g of x. This is another way of writing f of g of x. Raise your hand if you've seen this second way before. Some of you have seen the second way before. Yeah, some teachers will show you both ways. They mean exactly the same thing. It says here it means f following g, but it also means f of g of x. There's no difference in the calculation when you do this or when you do this. They're the same. So if you don't like looking at it when it says fog, you can do f of g of x, and that might make more sense to you. But these are the same. It says it right there. All right. You can do f of g of x where you put function g into function f. And you can do g of f of x where you put function f into function g. And generally you don't get the same answer except for in some very special circumstances. So if you found f of g of x but the problem said g of f of x, it's probably not the right answer in most days. All right, turn the page. That was quick. We'll do one of these together, and then you guys will do one. Actually, I'll tell you what, we're going to do 1A and 2A together, and then you guys are going to do 1B and 2B. Okay. So, this one's us, and this one's you. Okay. Quiet down. Thanks. We're doing f of g of x, which is the same thing as f of g of x, this way. So basically, we're putting function g into function f. There are a number of ways to think about this initially. I'm going to show you one way, but if your mind works better with a different way that you've seen before, that's okay. Like, the setups are equivalent, but sometimes they just look different at the start. So when I'm putting function g into function f, I'm going to replace the x value in f with g. So it's going to be 2, and then instead of x times g of x, plus 1. So I'm putting function g into function f, and I just literally replace the x with g of x. Now g of x, I know what that is. It's 3 minus 4x. So now instead of writing g of x, I'm going to write what it is. 3 minus 4x. So I'm putting function g into function f. And then I'm going to simplify. So I'm going to distribute and then combine like terms. So distributing, I get 6 minus 8x. And then combining like terms, I get negative 8x plus 7. Okay, so I'm going to do 2a before you guys do the b versions, okay? We're going down to 2a. So you could do this problem in a similar way where you put function f into function g, and then you put negative 1 into that function. But there's another way to think about this one, which is negative 1 goes into function f, and then whatever you get from f goes into function g. So negative 1 goes into the innermost function, and then that answer goes into function g. So first I'm going to do, bless you, f of negative 1. So I put negative 1 into f, and I'm going to get negative 11. Then I take that answer, and it goes into g. So g of negative 11. Here's function g. So I put negative 1 into f. I put that answer into g. And now I just have to evaluate. I want to show you, when they write this, we show you this writing because this is how the IB is going to write it on, your exam next year, and you don't want to see it for the first time there. But like what this literally means is f of x equals 2x plus 1. Okay? Their notation, I know, is like probably not something you've seen before, but you just need to adapt and understand it means this. All right, in this one, we're putting function f into function g. So I start with g and replace the x with f of x. Then replace the f of x with what it equals. All right, so a common mistake then is to subtract these two numbers, but order of operations tells us that multiply comes before subtract, okay? So you're going to take the negative 4 and distribute it. So I have 3 minus 8x and then minus 4. And then you can combine your like terms. What questions do you have? You're good? Okay, so this one is interesting. It's f of x. So you put 0 into f, and whatever answer you get, you put that into f again. So here's function f. F of 0 is 6 times 0 minus 5, which is negative 5. Then you take that answer, and you put it into f again. So it goes there. And that would be 6 times negative 5 minus 5. And I get negative 35. Did you guys get negative 35?
Yes.
All right. What questions do you still have on composition?
None.
Good. We have one more to do. This is like a real IB level question here, so we're going to read it carefully together. Some of you may have read it already, but I want to go through it together. The outside temperature at altitude A kilometers above ground level in a particular city is T of A equals 25 minus 6 A, and that's degrees Celsius. So degrees Celsius is just your what you're measuring. The altitude of the airplane T minutes after taking off is A of small t. So notice big T and small t are different variables. Equals 12 minus 60 over t minus 5 kilometers. Find the composite function T of A and explain what it means. So we're going to put function A into function T. So T of A, we replace A with this, A of T. Okay, so we're putting this function into this one. It's going to be 25 minus 6, and then replace A with the function A. Little t minus 5. So I replace the A with a whole function A. Just like before, I'm going to distribute that negative 6 like that. So I'm going to have 25 minus 72. When I multiply negative 6 times the fraction, remember that if you don't have a denominator, your denominator is 1. So don't multiply the 6 in both numerator and denominator, only on the top. And I have negative times negative, so that's going to make positive 360 over t minus 5. So I'm going to keep my fraction here. And I'm going to combine my two constant terms to get negative 47. And we're going to stop there. It is possible to get a common denominator, but I feel like your numerator will be so messy it's not going to be useful. I'm going to give you a second to make sure you got that, and then we're going to talk about what it means. Okay. This will simplify to big T of little t. Because little t is your first input, and then big T is your final output. What's really happening here is little t goes into function A, and then function A goes into function big T, and that can combine so that you have little t goes to big T. So what we're finding is big T. What does big T stand for? What is big T in this problem? Does it say? The outside temperature. The outside temperature is your big T. So it is the temperature and then their input is little t. What is little t? Minutes. So t minutes after takeoff. So they're saying that the time affects the altitude, and the altitude affects the temperature, so the time affects the temperature. Questions? Okay. The other one. If f of x has an inverse function, if it has an inverse function, this is what we call it. This means the inverse of f, right here. It's confusing because when you have a negative exponent, that also means reciprocal. You guys remember that? Like x to the negative 1 is the reciprocal of x? So in this case, if you have the exponent of negative 1 and it's on f, it's not on x, that means inverse, not reciprocal. People get confused by that all, well, reciprocal. Why can't I spell? Reciprocal. Okay, close enough. So when you see that negative 1 exponent, don't be confused and think I'm talking about x to the negative 1, which is the reciprocal. Instead, we're talking about inverse. It has to satisfy the horizontal line test. So you know that a function, for it to be a function, it has to pass the vertical line test. When we find an inverse, the x and y's are changed. And so now, instead of it being x equals a number, it would be y equals a number. It's a horizontal line test. And the graph is going to be a reflection across the line y equals x. The function y equals x is called the identity function. Because it's its own inverse. Okay, and over here, it's telling you that the domain of an inverse is equal to the range of the original function, and the range of the inverse is the domain of the original function. So they switch their domain and range. All right, so we're going to actually start by graphing this one. Just y equals 2x plus 3. How do I graph y equals 2x plus 3 without making a table of values? Where do I start? At the y-intercept, which is how much? 3. So this number is my y-intercept, is my starting point. 1, 2, 3. And I do a slope of 2 over 1. I'm going to make 3 points. And I'm going to graph it. If you have a straight edge, like even your student ID can be a straight edge, you can graph a nice straight line. Faster we get this done, the faster we get to the restroom, okay? All right. The inverse is going to, using coordinate geometry, the inverse is going to switch the x and y. So these points are, I'm sorry, you can't read that one. 0, 2, 1, 4, and 2, 6. If I want to do the inverse, I'm going to switch the x and the y. So this one becomes 2, 0, 4, 1, and 6, 2. So I want you to graph those 3 points on the inverse function. 2, 0, 4, 1, and 6, 2. All right. I want to check and make sure that I did it right, so because I want to look at the line y equals x and see if one line is reflected across the line y equals x. So this one here is f. This one is the inverse of f, I think, if I did it right. Bless you. The line y equals x is the line where y and x are all the same number. And so I'm going to plot 1, 1, 2, 2, 3, 3, 4, 4. That's going to give me that line y equals x. I should actually go through that corner as well. Okay. Okay, I'm off or something. I think I'm off because my dots are so big. But in general, you can see how if you reflected f across the line y equals x, which is this one, if I reflected it across, it would give me this one.
Maybe you need to use 0, 3. No, 0, 3.
Yes, that's why I'm off. Thank you. It's 0, 3, and then that would be 3, 0. So that should go up. I did go up 3. I just didn't go over 3 over here. And then I think this one's off too. Yeah. Did the other points make sense though? I had 2, 6. No, because I was up on 1. Okay. I'm going to fix it. Hopefully you guys use a pencil. All right, let's try. So we said we start at 0, 3, right? That's here. That's one of the points that I'm changing, 0, 3. And then I do a slope of 2, so the next one should be 1, 5. And then the next one would go up 2, and so that would be 2, 7. So these are the points I'm going to be changing. So this should be 3, 0. That's why my line was a little bit off. 5, 1. And 7, 2. Okay, so let me draw this line, and then I'll draw the inverse. So that's F. And then the inverse is when you switch them, and so I should have 3, 0, 5, 1, and 7, 2. Okay. And then if I graph that line, y equals x, now it should look a lot better. It should look like 1 is a reflection across the line y equals x. So here's my inverse. If I reflect this across the line, I get this one. The line is y equals x. So that's a graph of the inverse. If I want the equation of the inverse, I could find the slope and the y-intercept and find the equation. But there's another way to find the equation of the inverse, which is variable interchange. That's when you switch the x and the y. So I'm going to take the equation y equals 2x plus 3 and switch x and y, so it's x equals 2y plus 3. And you have to solve for y. So you'll subtract the 3. X minus 3 equals 2y. And then divide by 2. So I get y equals 1/2 x minus 3/2 or minus 1.5. All right, so in this one, we put the inverse into f, we got x. We put the function into the inverse, we got x. Therefore, they're inverses. And to find the domain, we just looked at the graph to see that it was negative infinity to infinity. All right, one more problem on the back. Okay, so consider the function, again, this means the same thing as y equals x squared, okay? It says explain why this function doesn't have an inverse function. I want you to think about that for a moment, why it doesn't have an inverse function. You can talk to a neighbor, you could graph it, graphing it might help you think about it, right? A lot of you knew the general shape of that x squared. 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9.
Isn't that a function?
All right, so that's the function y equals x squared, right? Right there. Graphically, how could I find the inverse if it had one? Switch x and y, for sure. Okay, so 0, 0 would stay in the same place. 1, 1 would stay in the same place. 2, 4 would become 4, 2. And then 3, 9 would become 9, 3. On the negative side, I have negative 1, 1, so that becomes 1, negative 1. Negative 2, 4 becomes 4, negative 2. And then negative 3, 9 becomes 9, negative 3. 1, 2, 3. Okay. All right, so I just drew the inverse function. So why am I saying that there is not an inverse function? Yeah, so it has an inverse, but it's not a function because it doesn't pass the vertical line test. Now, we didn't even have to graph it to know that, because you guys remember the test I told you to check to see if it has an inverse? It was the what? The horizontal line test. So you can look at a graph, and if it doesn't pass the horizontal line test, that means it doesn't have an inverse. Y equals x squared, of course, is a function, but its inverse is not a function. So we're going to explain that in any of those ways, okay? So we can say that when we switch the x and y, the new graph does not pass the vertical line test. Or you could say that the x values have more than one y. For example, when x is 4, y could be 2 or negative 2. When x is 9, y could be 3 or negative 3. So there are a few different reasons why this graph is not a function. But then it says, well, if y equals x squared, but we're only talking about this part where x is greater than 0, greater than or equal to 0. We're only talking about this part of the function. Does that part have an inverse? Yeah, let's look at it. It would be this part right here. You see that? If we're only talking about the part where x is greater than 0, then we're okay, because we don't have this over here, and we don't fail the vertical line test. Okay, so yes. Just using the right side will work. So that's what they do. When they want to talk about the inverse of a quadratic function, they have to limit the domain to just half of that so that it will work. So you just pick that out. Okay? So to find the inverse for x is greater than or equal to 0, we have y equals x squared, and then we switch the x and y. And then how do I solve for y? Square root. So normally, we would square root both sides and we would do a plus or minus. However, we're only using the x is greater than 0, so we don't use the minus. Not the minus. Okay, so we just have y equals square root of x. We're only using the positive side because we limited our domain. So it says to sketch f of x. We did that. We didn't sketch y equals x yet. And then it says sketch the inverse. So we did all that except for just not the line y equals x. So the line y equals x, remember, is going to be 1, 1, 2, 2, 3, 3, etc. And so it's going to look like that. Okay, so you can see that the original function reflects across the line y equals x and gives you the inverse function.